Okay, in this video we're focusing on solving linear equations, and what that is where we have a single variable. So let's take a look here what we're looking at. So we have a x to the first power here, here, here. So we're basically just solving equations. One line, nothing more than that. Now the key to solving equations, I'm going to put one big note here at the top, is simply get the variable, in this case x, by itself. And the key to doing this is you have to undo what's there. So, for instance, what do I mean by undo? If you see addition, how do you undo subtraction? You do subtraction. You do the opposite. Subtraction is opposite addition, so you just go, vice versa there. Multiplication and division are opposite. So you see multiplication, you do division. So when I see this, a good way to look at it is like the equal sign is like the divider, and the goal is to get the x, the only thing on that side, and that's how we'll call this isolating the x. So we look at, okay, so we have x plus a 7. How do you undo 7? Well, if we subtract 7 right behind it, then we can do that. Now, in all equations, you can do anything you want as long as you're equal to both sides. Just like if Bob had $10 and Jimmy had $10 and they're equal, if one loses $7 and you want the other one to lose $7 too, they have to do that in order to stay equal, okay? So if I subtract 7 from one side, I do it to the other. It's very important to show that work there. So then that cancels out. So you just have x is the only thing over here. And then 4 minus 7 is negative 3. You know you're done when the variable is the only thing left on that side of the equation. So we get to simply say x is equal to negative 3. Okay, the same thing over here. First put my division in. X, we have this negative 12 on the same side as x. I want to move it, so I do the opposite. Do it to both sides. And we have x is equal to 15. Okay, and then that's what I'm looking for there. And I know I'm done the moment that I see x is the only thing left on that side of the equation. Now over here we see a multiplication, negative 6 times x. So how do we undo that 6? We divide by negative 6. And notice they cancel each other out. If we do it to one side, we do it to the other, and x is equal to negative 8. Simple as that. Now the same thing over here, notice p's on this side of the equation. Okay, so and again, it could be any variable. I put x up here because a lot of people like to default to that, but really it's any unknown, and it could be really any letter represent that. So here, p's on this side, doesn't matter what side it's on, but we have this negative 5. The negative is also in the way, so I'm going to divide by the negative as well. So divide by negative 5 over here, and then we get, now notice, a negative divided by negative is a positive, so we have to switch that sign there, and p is equal to 13. So this is a very basic introduction to what we're looking at here. Okay, now the same thing happens here. What if we have fractions? How do we handle that? Well, we could say, well, let's undo the 4 by dividing, and let's undo division by multiplying. Well, we could do it all at the same time, and we call that the reciprocal. The reciprocal is when you have a fraction and you flip it. Okay, so I'm going to put a little symbol here, and we flip the fraction. So let's take a look here. So let's multiply this by the flip. So I'm going to take the 5, put it on top, and then put the 4 on the bottom. And what that does is, notice the 5's cancel and the 4's cancel, so we basically eliminate the fraction. So if I say, what's the reciprocal of 2 sevenths? We say 7 divided by 2. What's reciprocal of 12? Well, we can make that into a fraction and say, okay, let's flip it and make it 1 over 12. Notice, how do we undo 12? We divide by 12. So reciprocal is a way to show that multiplication and division are really the same thing. Same thing here. What's the reciprocal of 1 over 4? 4 over 1. Okay? Or you can simply just say 4. So looking at this example here, we see, okay, we have 1 over 4. So this is just like this example here. So I'm going to multiply it by 4 over 1, both sides. Okay. So notice the 4's cancel. It's the only thing left over there. So x is the only thing left right there. And 5 times 4 is 20. Now notice, I put 4 over 1. It's the same thing as this regular 4. If you want to make that into a fraction, so you can see that. So it's 20 over 1, i.e. just 20. No big deal. Okay, so we look at this one. How do we undo this? Well, what we want to do is we want to multiply by the negative as well. So I want to multiply by 7 divided by 2. And we can see that in this example right here. The two negatives cancel each other out, and x is the only thing over there. If we do it to one side, we got to do it to the other. 7 divided by 2. Okay, so again, we did this in previous videos. We have 4 divided by 1 and negative 7 divided by 2. So I'm going to cancel those, that 4 and that 2. So that goes in there 2 and 1 times. 2 goes into the top and bottom. Okay. So we have 7 times 2, negative, so that's going to be negative 14. Okay. So that's what we're looking at there. This one, same thing here. The key is to multiply both sides by the reciprocal. I see 5, 6. I'm going to do 6 divided by 5, both sides. 6 divided by 5. And again, a lot of times you want to make that into a fraction perhaps so you can see it. Notice on this side here, I'll change colors. Cross out, so W is the only thing left. Okay, so there's my equal sign. I like to put a little wall there. I visually like to divide that. And then we'd say, okay, 5 goes into 10 2 times and 1 time. So 2 times 6 is 12. I always like to reduce early. Otherwise, you could go 60 divided by 5 and then reduce at the end. No big deal. But that's how you deal with reciprocals. Okay, now in these examples, we have multi-step, meaning we're going to have to do several things to get x by itself. So let's take a look at the first example. First, I put my division in there, my dividing line, meaning equal sign. And I'm going to highlight the x's in all these problems. We have one there. We have a couple here. One there and one there. So I'm first identifying where's the unknown at. And what we're going to do is say, how do we have to get this by itself? Now, I always like to start furthest away. We got to move this 9, which is being added, and then we have this 5, which is being multiplied. So how do we move this 9? We subtract. I want to do this first. I can't really divide by 5 first. I got to first move this over. So I'm going to do minus 9. So then we have 15 is equal to 5x. Rewrite the equation every single time. And notice that this comes down. Now, how do we undo multiplication? We divide. Okay. Algebra, in this sense, is basically logic, but just systematic. We have a system. So if I said, solve this in your head and you talked it through, you would be doing the same thing. You'd be moving 9, you'd be dividing by 5, and so forth. So 15 divided by 5 is 3 is equal to x. So there we go there. Okay, now over here, this is like the last topic. We have 2 x's, so what do? Well, the first thing you want to do is you have to isolate it, you have to combine it. So 4 minus 8 is negative 4x. So we just simply do that. Okay, and then we say, okay, how do we undo negative 4? Well, we're going to divide by negative 4 both sides. And we have x is equal to, what's that going to be? Negative 16. Okay. So notice we have 2 steps. First step combining here, and then division. Okay, so look over here. So the first thing I'm going to do is move that 7. Okay, because we have the 7 in the way. It's being subtracted, so I'm going to add it. So now we have x minus 3. It's very important to copy everything down that's left over. So negative 1 plus 7 is 6. Okay, we have a reciprocal, so 3 is on the bottom. So I'm going to multiply it by doing 3 on top. Okay, so a lot of people do it like that. You can do 3 over 1 if you want. But notice those cancel. 6 times 3 is 18. Okay, so 2 steps there. First we move the 7, and then we move the 3. Okay, over here, we're going to add 8 to both sides. So we have 5 divided by 6, c is equal to 15. Now here we have 2 pieces, so I'm going to go ahead and multiply by reciprocal. 6 fifths, do it to both sides. 6 divided by 5. I'm going to change that into a fraction so I can see it. And we simply have elimination there. C is equal to, now here, 5 goes into 5 one time, 3 times. 3 times 6 is 18. So there's your answer there. Now notice in this one, what I'm going to do is, even though the x is an x, it's still a number. So if it's on the bottom, just like we did over here, how do we undo this 3? We multiply it. So I'm going to multiply by x both sides. And notice the x's cancel. And you can do that. So now the x is on this side of the equation, and that's completely okay. And now you look at it and you say, and the thing about algebra is you look at each step as an independent problem. So now looking at this problem, can we solve this? Oh yeah, it's no problem. Now you move the 9 over, and 4 is equal to x. Okay, so that's a real good example of what we're looking at here. So, sometimes we're moving numbers. Sometimes you got to move the x. You would like to get the x upstairs in the numerator and not leave it down there. Okay, now here's just some more examples of multi-steps. I'm going to do a couple of them here, and then I will have you do a couple. So I want you actually to do this one, and this one. When I go through these 3 examples, I want you to pause and try those on your own. So let's talk through this one here. Okay, so first I'm going to identify where's my unknowns at, right here and right here. So I'm going to first combine those two elements. 9 minus 2 is 7x plus 4 equals 32. Okay, so first get the x together. Now we got to move this 4 because it's in the way. So I'm going to move the 4 by subtraction, and 7x is equal to 28. Last step, how about undo multiplication? So I don't even care what the number is. I'm looking at the operation. That's multiplication, so I'm going to divide. So x is equal to 4. Now a good thing to do is you could always take your answer and plug it in. And let's show, that's a good way to check it. So I'll do it here in blue. Do it right up above it. I'm going to take 9, plug in 4, minus 2, plug in 4, and then add 4, and that should all equal 32. And let's see if it does. So 9 times 4 is 36, minus 8, plus 4, does that equal 32? And if you go through it, plug it into your calculator, or do it in your head, yes it does. So you can verify if an answer is correct or not. Now let's look at this example here. Now the first thing I want to do is order of operations. I don't want to have parentheses here. So I'm going to distribute that 3. So 3 times y is 3y, and then 3 times 4 is 12. Okay, now, just like this problem here, we have 2 y's. So I'm going to combine those to get 5y, combining like terms. Okay, next step, move the 12 because it has nothing to do with the y. So we have 5y over here is equal to 15. And last step, divide by 5, and it's going to write it off to the side here. Ran out of room. X equals 3. Okay, so again, multiple steps, just go through the process. The key is look at one thing at a time. Okay. Now let's go ahead here and look at this example here. I'm going to do it in a different color at the right over the top here a little bit. So when I see this, this is a fraction times, now even though the variable m is inside the parentheses, what I have to do is first get the parentheses all by itself. Now a lot of people want to distribute that, but I'm going to show you a shortcut to get rid of this fraction. I'm going to multiply by the reciprocal. So when I see this, this is 3/4 times googly moogly. I don't really care what's inside the parentheses. There's some of the variables in there somehow. So first I have to get rid of this. So I'm going to multiply it by 4/3, both sides. So 4/3, okay? So now those cancel, and the only thing left over here is m minus 6. And then 3 goes into 12 4 times. 4 times 4 is 16. Okay. Now, notice there's no fraction and no parentheses. So it's a very quick way to get rid of both of those. So add 6 to both sides. Again, there's my division line. And m is equal to, what's that, 22. Okay. So real good example of what we're looking at here. Okay, so now would be a good time to pause. Why don't you go ahead and try these 3 examples, and we'll take a look at those. One last example I want to show you are these 2 problems here. So we have 2 separate problems. And notice here if I say, okay, let's first get the x's together. So we have x's on 2 sides of the equation. So I'm going to move an x over. And you can do that. Just like moving numbers, you can move x's. So notice the x's cancel out. So you have nothing. So you have 3 equals 6. And you're looking at this, well, where do the x's go? And 3 doesn't equal 6. So you have to ask us, does this ever happen? And we would say never. So that means that there's no solution. There's no answer that we could put in this equation that would make it solve. It's just a false equation. So if you get a statement where the variables drop out and the statement's false, never happens, no solution. Over here we have a separate scenario. Let's distribute that 4. Let's distribute the 2. And notice they're the same on both sides. So let's move the x over to the other side. So notice we have no x's, and we have 24 is equal to 24. And we can kind of see that here. They're the exact same. If they're the exact same, it says when does this happen? Will 24 equal 24 always? And when it happens, that means that we call it infinite number of solutions. And what that means is I can plug any value in for x. I can plug in 100. I can plug in -2. I can plug in 16. And it will always work out because the 24 always equals 24. So here's a great example of never happening and always happening. And we'll see this better represented on a graph, but algebraically, that's what we're looking at right here.